Alright, so let's proceed, class. So before we start with our next lesson, class, let's first discuss your quiz from last time, which is about aminoglycoside dosing. So actually, most of this pwede naman sagutan na lang using the Excel sheet. Pero I saw some of you guys did the manual. Okay, nakakatuwa. And thank you very much for doing that. Okay, so anyway, class, let's go. So here, class, we have a case of a 45-year-old female who is admitted to general medicine with severe pyelonephritis. So admission data includes serum creatinine, which is 0.9 milligrams per deciliter. Weight is 165 pounds. Height niya is 5'9", so that's equivalent to 69 inches. Okay. Then the attending physician ordered 300 milligrams of gentamicin as loading dose and 150 milligrams as maintenance dose every 8 hours. Okay, so both loading and maintenance dose will be infused for 1 hour. So tips daw in dosing this one. In this specific case, for this specific case, okay, aim daw natin ang peak na 6 milligram, 6 micrograms per ml. And then keep the trough concentration at 1.5 micrograms per ml and below. So kumbaga, as much as possible, we don't want the trough concentrations to go beyond 1.5. Okay? So ang question here, class, is using the dose proposed by the physician, what would be the expected trough concentration of the loading dose? Now, actually, class, in reality, we don't really get the trough concentrations. Pero gusto ko lang tingnan kung kaya nyo bang i-compute on your own. Okay? Pero normally, class, pag loading dose, titingnan natin dito is yung peak concentrations. Okay? Sa maintenance talaga tayo nag-check for trough concentrations. Okay? Kung kailan nasa steady state concentration na yung ating gamot. Right? So let's go, let's use, class, our Excel sheet. So sa dose checking tayo. Okay, so sabi dito, ang maintenance dose natin was 150 mg. Actually, wag na lang to. Dito na lang tayo sa ano. Ba't nga ba ako dumiretso dyan? Let's go first to female dosing para lang magets natin kung ano yung dapat. Kasi natin kung ano nangyari pag mali ang binigay. Okay, so ang age ng patient natin kasi is 45 years old. Height is 69 inches. Weight in kilogram is 165 by 2.2. I think that's 75. 2.2. Yep, 75 kilograms. Okay, so based on our Excel sheet, gagamit tayo ng adjusted body weight, which is 66.2. Okay, then ang serum creatinine natin is 0.9 milligrams per deciliter. Alright. So ang creatinine clearance ng patient natin is quite low for her. Okay. Then now, class, our K, or our elimination rate constant, will be 0.2557. Okay? 0.2557, tama. Alright. So, ang aim natin, class, na peak concentration is 6. Based on our, based on the case. So, we'll go daw for 6. Normally, it's 7. Okay? Pero sabi dito is 6 na lang daw. Trough concentration natin, class, will still be 1. Remember, ang kailangan natin lagi sa ating, ang kailangan natin lagi sa aminoglycoside is a trough concentration that is 1 or lower. Okay? Pwede tayong mag-low concentration. Remember that. Okay? For one main reason. Ano nga ba yung reason na yun? Bakit pwede tayong trough concentration mas mababa pa sa 1? Anyone? Okay, why is it allowable na kahit mas mababa pa sa 1 ang trough concentration mo, kiri-boom-boom lang? Okay, for aminoglycoside dosing. So this is one specific for gentamicin. Right? Can anyone tell me why it's okay to go for a trough concentration less than 1? Okay. Baka nahihiya lang. Okay. Sino gusto mag-share? Uy, nahiya. Or nasanay lang na pre-recorded na lahat, wala nagtatanong. Alright. Anyone? Huwag na mahiya. Try nga natin, Miss Guyagoy, andyan ka ba? Yun. Hi! Ay, pwede rin pala mag-type, tama. Okay. Try nga natin, Miss Guyagoy. Bakit sa tingin mo, pwede tayong mag-go below sa ating trough concentration, which is 1. Okay, pwede nyo namang i-type yung sagot nyo kung nahihiya kayong magsalita. Okay. Well, we can summarize it in 3 letters. It's called the PAE. Because of its long PAE. Ang acronym yun for? Right? So it's a PAE. Long PAE ng ating, yan. PAE ng ating aminoglycosides. Right? Okay. So sige. Siguro? So dito. Tapos na yung quiz eh. So class, it has a long post-antibiotic effect. Okay. So ibig sabihin, kapag na-expose ang bacteria sa aminoglycosides, okay, kahit na matagal na, okay, or even if the trough concentration is already below the allowable trough concentration or the minimum trough concentration, it's okay because aminoglycosides can still exhibit their long post-antibiotic effects. Okay, so ibig sabihin nakakapatay pa rin siya ng antibiotic ng bacteria kahit below na siya sa kanyang minimum trough concentration. That's why class, it's advisable that we don't go beyond 1 as much as possible. Lalo na pag 2. Okay? Kasi it still exerts its antimicrobial property. Plus the fact din class that the lower the trough concentrations, okay, the better for one main reason. It prevents what we call yung side effects ng aminoglycosides natin like ototoxicity or nephrotoxicity. So we try to keep it below the trough concentration as much as possible. Okay? Pero sabi dito, wag lang daw tayo susobra sa 1.5 kasi ang allowable for aminoglycosides, specifically gentamicin, is between 1 and 2 mics per ml. Okay? So basta wag lang daw tayo mag-go beyond 1.5. Right? Pero still, of course, ang desired trough concentration natin will still be 1. The lowest possible. So infusion time is 1. Okay, then ang sabi dito, ang kanyang dosing interval daw is 8 hours. Pero yung loading dose niya is 300, right? Okay, so 300 milligrams ang binigay na loading dose. Now, kung titingnan natin yung class, a 300 milligram loading dose will result to a 16.66 micrograms per ml na peak concentration. Alright, so that's the peak concentration. We remember class, diba, when we do trough concentration, so C trough, it's just C max times E negative KT prime. Okay, when we want to get trough concentrations. So therefore, class, ang C max natin, so if we want to get a trough concentration for the loading dose, so sabi nga natin is 16. Ano nga ba yun? 16.66, okay, milligrams per liter times E negative K, which is 0.227 something. 2557, sorry. 0.2557 times T prime natin, di ba, class, is infusion time, dosing interval minus infusion time. So that's 8 minus 1, so that gives us 7. Okay. So 16.66 tapos shift ln negative 0.2557 times 7 times 0.166977 times 16.66, get an answer of 2.782 milligrams per liter. Okay? So therefore, class, the correct answer for the first question is, yun na nga, 2.782 milligrams per liter. Okay? So in connection to the question above, what about the proposed maintenance dose of the physician? What would be the expected trough concentration of the proposed maintenance dose? So here, class, balikan natin yung ating Ang recommended dito na maintenance dose is 94.07. Okay? Pero ang binigay ng physician natin is 150 milligrams. Okay, so if it was 150 milligrams class, ang lalabas na peak is 9.57. Tapos ang trough concentration is 1.6. Now, remember what the case told us. Ang sabi ng case, wag daw tayo mag-go beyond 1.5 as much as possible. Although allowable ang 1.6, pero for this specific case, wag daw tayo mag-go beyond that. Okay, so obviously class, hindi na acceptable yung maintenance dose na binigay ng physician natin for our patient. Pero technically, pwede pa rin naman talaga siya. Kasi pasok pa siya sa between 1 to 2 micrograms per ml na trough concentrations. Right? Pero anyway, class, yun nga, ang expected na trough natin is 1.6. So that will be 1.597 here. Okay? Alright. So what's the patient's creatinine clearance? Balikan lang natin dito. It's a 0.9. Serum creatinine to, sorry. 82.49. So dito tayo. Excuse me. So ito yung ating creatinine clearance. Okay? Wait lang. Baba natin konti. Okay. So yon. The next one, how long will it take for the drug to reach steady state concentration? So for this case class, oops, pindot ko na agad. We just need to check for the half-life. Andito lang naman yan sa gilid eh. Alright? So half-life is 2.71 and time to reach steady state is 14 hours approximately. So that's 13.55, 14 hours. Ito yung tamang sagot natin. Okay? Then what will be the appropriate dosing interval for the drug? Okay? For this one class, okay, somehow nagkamali ako ng pinindot dyan. I don't know why. Okay, dapat kasi 08.01. Pero 8 hours pa rin naman. Okay? So, ang ginawa ko lang dito, class, 0 points ko na lang siya. Alright? Kumbaga, bonus na lang yan. Alright. So, next one. What would be an appropriate loading dose for gentamicin? So, the appropriate loading dose class would be 108.03 here. Okay? So, syempre, wala naman tayong dose na ganun. So, pwede natin to i-round up to 110. Which is lalabas na peak concentration 6.11. So, okay na yun. Pwede na yun. So, that's an okay peak concentration. So, for this one, the correct answer would be 108.03, which is 1, or just give 110 milligrams. What would be an appropriate maintenance dose for the patient? So, the appropriate maintenance dose would be 94.07. Hirap naman ibigay yan. So, round up natin yan to 100. Okay, so ang trough concentration is 1.07, which is still allowable, right? Sabi natin kasi go below 1.5. Right? So, the correct answer would be 94.07. So, 100 milligrams. Goods na yun. Okay? Then what would be that expected trough concentration for the computed maintenance dose? That's 1.07 or 1.065. So, ito siya. Here we are. Okay? Now, continuation of the case. So, after 72 hours of treatment, patient's severe pyelonephritis started to subside and the patient's serum creatinine was taken. Okay, patient's serum creatinine was 2.4 milligrams per deciliter and was found to be too high. Patient is to be started on extended dosing interval to continue with his treatment of gentamicin. Okay? So, tumaas daw kaya serum creatinine to 2.4. So, kung 2.4 yung class creatinine clearance natin, it will be 31, approximately 31. So, ito yung magiging sagot natin. 30.94. Now, class, based on the extended dosing interval, so may graph naman tayo dyan. May nomogram. Okay, all you need is to determine the serum creatinine. Tapos, check nyo na lang doon kung anong dose ang gagamitin natin. Alright? So, anyway, class, ang lalabas dyan would be 187.5 or approximately 190 milligrams ang ibibigay sa patient every 24 hours. Alright? Okay. Any question, class, regarding our quiz from last time? May katanungan ba tayo? Any questions, class?
Sir, bali po yung sa last question po.
Yes.
Ginamit na weight ay yung
actual
po.
Yes, actual body weight to.
Sige po, sir. Thank you po.
Okay. Kasi remember class, di ba? Isa sa mga instructions, pinaulit-ulit ko sa yung sa video lecture natin. Na pagdating sa extended dosing interval, hindi natin titingnan kung yan ba ay gagamit ng ideal body weight. Okay? Normally class, we will immediately use the actual body weight. Not unless, yun na nga, the patient's body weight is 30% higher, is more than 30% higher than their actual body weight. So hence, we started to use adjusted body weight. Okay? Pero in this case, ang weight ng patient ko, 75, di naman ganun kataas. Alright? Ayun. Okidoki. Right? So kung wala ng question class, I think we can start with our discussion on our next topic, which is all about vancomycin. Okay. So let's start our discussion class on vancomycin. So first and foremost class, I think most of you guys are familiar with vancomycin, right? Especially those who just took their board exams. Ay, sorry, lahat pala kayo nakapag-boards na. Kabilang section nga pala yun. Okay, pero class, vancomycin is generally established as the drug of choice for what type of infection? Okay, it's a drug of choice for what type of infections nga ba? Matunog na matunog din to nowadays eh. Okay. Anyone? Yun. Wait lang. Sige. Very good, Miss Makaraeg. Okay, so we have the MRSA. We call this the methicillin-resistant Staphylococcus aureus. Right? So very good. So correct class, vancomycin is the drug of choice for that kind of infection. So class, normally, some things that we have to remember about vancomycin, it's usually administered via intermittent IV infusion. Okay, it has poor oral absorption. Kaya normally class, we don't give vancomycin orally. Not unless, okay, may isang specific type of infection class that would require you to give vancomycin per orally. Okay, try lang natin kung naaalala niyo pa yon. Okay, ano nga ba class ang type of infection that would merit the use of an oral vancomycin? Okay? Kasi technically class, may poor oral absorption yung vancomycin. So it doesn't make sense to make an oral dosage form of vancomycin. But there is an oral dosage form for vancomycin, and it's only used for one specific type of infection. Okay? Yun, very good, Miss Guyago. It's C. diff. Okay? Or what we call the Clostridium difficile. Alright? So yun lang class ang tanging time na gagamit tayo ng oral vancomycin. Okay? Now normally class, ito nga the thing is, yung tablet form kasi ng vancomycin is very expensive. Parang twice the amount of the IV. Kasi yung IV, meron ng mga generic counterpart to eh. Kaya in some hospitals class, what they do, pag may C. diff infection ng patient natin, instead na bibigyan nila ng oral dosage form, na oral na vancomycin yung patient, ang ginagawa class, yung ampule, nilalagay sa capsule. Tapos yun na binibigay sa patient. Okay, well, pwede rin naman yun eh. Wala namang problema. Okay, some hospitals do that. Okay? So, ayun. Anyway, so vancomycin class is a drug of choice for MRSA, methicillin-resistant Staph aureus, and enterococci group D strep. Now, normally class, doses that are greater than 700 milligrams are often diluted in large volume parenterals. So meaning class, if the dose that you're going to give is going to exceed 700 milligrams, okay, normally class, dinadilute niyan sa large volume parenteral, like 250 ml NSS. Okay, and which will be infused class for 2 hours. Now, the standard infusion time class for vancomycin is 2 hours. Okay, kasi we try to prevent Redman syndrome from happening. Redman syndrome class normally happens pag fast drip si vancomycin. Kaya ang advisable lagi is 2 hours na infusion time for vancomycin. That's the standard. Pero class, there are cases wherein some physicians will go for 1 hour. Na pwede rin naman yun, wala namang problema. Basta class, make sure lang na pag mag 1 hour ka, less than 700 yung dose na bibigay natin. Like 500 milligrams, pwede naman yan. Okay? So, yun. Right? And then, class, normally, ini-infuse, dinadilute nila yun sa 100 ml na NSS. Okay? But, then again, as I've said a while ago, class, most of the time, 2 hours pa nang gagamitin natin. Okay, na infusion time. Now, in our case, class, here in our class, I will always require you guys to use 2 hours of infusion time. Okay? Yeah. Now, another thing, class, that we have to remember about vancomycin is that it follows 2-compartment model. Okay? Ano bang meron sa 2-compartment model? A standard 1-compartment model kasi, class, follows a linear regression. Okay? So, meaning straight yung kanyang decrease in plasma concentration. If you give a drug intravenously, it starts at the peak, at the highest concentration possible, then declines following first-order kinetics. The thing, class, with 2-compartment model is that merong distribution phase bago siya mag-start mag-eliminate. Now, this distribution phase, okay, causes the drug, class, to transfer from the bloodstream to other compartments. Specifically, class, in the case of vancomycin, it transfers to our adipose tissues. Okay, so alam naman natin, class, na kapag ang gamot ay nasa adipose tissues, walang magagawa yan kasi andyan lang siya. Parang na-store lang siya. Okay? Pero after a while, class, okay, from the adipose tissues, ibabalik din naman yan sa bloodstream. Okay? Then it starts to follow first-order kinetics. Now, when we compute, class, for vancomycin dosing, okay, we have to put into consideration itong distribution phase na to. How long does it take bago mag-terminate yung distribution phase? Kasi, class, we only start getting plasma concentrations after the drug has already reached, after the drug has already finished its distribution phase. Kasi, class, pag dito tayo kumuha ng plasma concentration, halimbawa, kuha tayo ng C-peak, C-trough. Ang peak natin dito natin kinuha. Okay? And during that time, class, lumilipat pa yung vancomycin sa adipose tissues natin. So, it will give you a wrong estimate of the total amount of drug in the bloodstream. Okay? Kaya normally, class, pinapatapos mo natin yung distribution phase na yun before we get peak concentration. So, normally, ang peak concentrations natin, dito na natin napupulot yun. Or dito natin kinukuha. Andito na yung C-peak. Hindi dito. Okay? Not here on top. We don't get it there. Okay? Kasi nga, it's gonna give you an overestimate amount, parang ma-overestimate yung total amount ng drug na sa system mo. Right? At least dito kasi sa bandang ito, stable na yung elimination ng ating gamot. Dito sa may after the distribution phase. Okay? So, yeah. Now, normally, class, distribution phase can last between 1 to 3 hours. Alright? Pero normally, class, it's about 2 hours. Okay? That's the safest estimate that we can use. Okay, to determine kung tapos na ba ang distribution phase ng gamot natin. Excuse me. Okay? Alright. Oh my God. Okay, let's just wait. Ayan. Sorry, nawala ako, class, no? I was gone for a bit. Ayan. Ayan, okay. Okay na ba ulit? Okay. Nope, that was me. Ay, parang nag-fluctuate yung internet ko. Anyway. Sana ba ako? Ayun. So, class, again, sabihin ko lang na, anyway, at least yung recorded video natin tuloy-tuloy lang to. Okay? So, anyway, so once again, class, the thing is, ang distribution phase ng vancomycin normally lasts between 1 to 3 hours, pero standard natin is 2 hours. Okay? So, ibig sabihin, after 2 hours, after infusing the drug, we have to wait for 2 hours more. Okay, di ba nag-infuse tayo for 2 hours. So, pagkatapos ng infusion, class, mag-aantay tayo ulit ng another 2 hours bago tayo kukuha ng peak concentrations. Okay, kasi at least after 2 hours, medyo stable na yung plasma concentration ni vancomycin sa katawan natin. Okay? Ayan. Now, other vancomycin facts. Okay, so the trough concentration, class, is the most important, similar to aminoglycosides. Okay? Trough concentration ang madalas binabangan natin para ma-determine kung safe pa ba si vancomycin o hindi. Now, normally, class, ang trough concentration na hinahanap natin is between 5 and 10. Okay, pero we can always go beyond that level. Okay? Now, pag ang inyong bacteria class, okay, pag ang bacteria natin is, tawag dito, susceptible to vancomycin, okay, ang MIC niya or minimum inhibitory concentration is less than 1, then class, ang trough concentration natin should be greater than 10 milligrams per liter. Between 10 and 15. Okay? Mas mahusay daw yon. Now, class, bakit natin ini-aim yung greater than 10? Or saktong 10, pwede rin naman. Okay? Pero we try to go beyond 10. Huwag lang sobra sa 15. Yun lang, ha? Okay? Basta between 10. Greater than 10. Now, class, the reason for that, class, is we want to avoid the development of any resistance. Okay? So, gusto natin mamatay agad yung bacteria. Alright? So, ang trough concentration na ini-aim natin is greater than 10. Unlike kasi, class, aminoglycosides, vancomycin doesn't really have that much of a long post-antibiotic effect. Okay, si aminoglycoside kasi kahit below ka sa trough concentration mo, carry lang. Kasi nga, it still exerts antimicrobial properties. Pero vancomycin class, pag nawala siya sa concentration niya, sa trough concentration niya, nawawala rin yung kanyang efficacy. Alright, so it should be greater than 10 milligrams per liter. Now, if the MIC is saktong 1, okay, we go for a trough concentration that's greater than 15. Okay? Greater than 15 milligrams per liter. Now, if the infection class is complicated, okay, let's say, for example, bacteremia, ito meron ng sepsis, hospital-acquired pneumonia, endocarditis, meningitis, osteomyelitis, mataas na yung requirement natin for trough concentrations. Okay? Our trough concentration requirement class becomes between 15 to 20 milligrams per liter. So, ito class ang kailangan kong matandaan ninyo. Okay? So, kailangan it's between 15 and 20. Okay? Beyond 15 and 20. Now, again, kung susceptible, basta greater than 10, okay na yan. 11, 12, 13, ganyan. Okay lang yun. Okay? Now, normally, class, you find nephrotoxicity and ototoxicity in patients whose trough concentrations are greater than 15 milligrams per liter. Now, class, kailan naman natin ito gagamitin? Gagamit na naman tayo ng ganitong trough concentrations kapag ang MIC ng patient natin, MIC ng bacteria, is equal to 1. Ibig sabihin, class, medyo resistant na yung bacteria na yun sa vancomycin. Alright? Eh, yun nga lang, class. Sabi nga natin, the patient will start to experience some side effects. Pero between the bacterial infection class that's killing you and the nephro or ototoxicity, anong pipiliin ko? Okay, so personally, class, kung ako yung pasyente, doon na ako sa titiisin ko na lang yung nephrotoxicity. Okay, at least yan, pag tinigil ko yung gamot, nawawala rin naman. Alright, pero kasi itong infection na to, like bacteremia, endocarditis, meningitis, osteomyelitis, can kill me. Okay, kaya akong patayin ng infection na yun. Right? So, tiis-tiis na lang ako ng konti, right? Okay. So, how do we estimate the elimination rate constant and the volume distribution of vancomycin? Actually, class, yung computation ito, very similar to aminoglycosides. Okay? So, we'll still be using population estimate. So, the VD for vancomycin varies widely, but a commonly used average of vancomycin is approximately 0.9 liters per kilogram of the total body weight. Okay? Total body weight. So, ibig sabihin, class, this time, okay, hindi na natin ko-consider kung ideal body weight or adjusted body weight. Basta kung ano ang weight ng patient, yun na yun for vancomycin. Because, class, the weight of the patient itself can affect the volume distribution for vancomycin. Right? So, it's 0.9 liters per kilogram of the total body weight. Okay? And so, unlike aminoglycoside, total body weight is used, not the ideal body weight. Now, for the elimination rate constant, so similar, class, kailangan natin pa rin yung creatinine clearance. Now, just remember, class, sa creatinine clearance, ang computation yan is still based on ideal body weight. Not unless the actual body weight is less than the ideal body weight, then we use the actual body weight. Okay, or when we start to use adjusted body weight, if it's the actual body weight is 30% higher than the ideal body weight. Okay? Okay, so ito yung kanyang standard line ulit. But then again, class, again, it's a population estimate. Right? Okay, so let's have here a sample case problem. So BW, a 42-year-old man, 5'10" in height, weighing 90 kilograms, is admitted to the hospital for right colectomy, because of colon cancer. Initially, he has normal renal function. Serum creatinine is 1 milligram per deciliter. He subsequently developed a post-operative wound infection, which is treated with surgical drainage and an IV cephalosporin. Culture of the wound fluid revealed that S. aureus with a vancomycin MIC. Class, before I proceed any further, familiar ba kayo sa term na MIC? Minimum inhibitory concentration. Are you guys familiar with this term? Baka may binabanggit ko to, hindi pala familiar sa inyo. Anyone? Familiar ba kayo sa word na MIC? Okay, hindi pa familiar. Sorry. Alright? So class, MIC stands for minimum inhibitory concentration. Meaning, this is the concentration of the antibiotic, the lowest concentration of antibiotic that can inhibit the growth of a specific bacteria. Now, normally class, siyempre bawat bacteria may kanya-kanyang strains yan, di ba? May mga bacteria na resistant, may mga bacteria na susceptible. Okay? So normally class, whenever you have an infection, pwede mo itong i-request sa laboratory. Okay? Para ma-determine kung ano yung MIC concentration ano yung minimum inhibitory concentration nung antibiotic mo at sa bacteria na yon, sa bacteria na nag-infect sa'yo. So normally they do serial dilution or they do plates. Okay, so various concentration ng antibiotic, usually doubling in dose. Okay, so halimbawa, start ka as 1 milligram, tapos magiging 2 milligrams, 4 milligrams, 8 milligrams, hanggang 16 milligrams, kunwari. Usually doubling doses. Tapos, out of this 5 concentrations class, ano ang concentration na pinakamababa na walang growth? Let's say, for example, ito yung test tubes. Kunwari, kumuha ako ng blood ng bacteria sa patient ko. Nag-culture ako ba? Nag-culture tayo. So, kunwari, gagamit ako ng 5 test tubes. Lahat yan lalagyan ko ng bacteria. Lahat may nutrient broth, ha? Lagyan ko ng bacteria, kunwari S. aureus. Tapos lahat ng test tube na to class, may kanya-kanyang concentration to. Kunwari, 1, 2, pero doubling doses to, ha? 1, 2, 4, 8, 16. Now, kapag nagkaroon class ng bacterial growth, ano nangyayari sa test tube? Di ba class yung test tube natin nagiging turbid? Right? Turbidity class indicates bacterial growth. Okay? So, kunwari class, at 1 milligram yung vancomycin, turbid pa siya. Nung 2 milligrams, turbid pa rin. Okay? Turbid pa rin yan. Now, class, yung on the 4 milligrams, 8 at saka 16 milligrams, clear yung nutrient broth mo. Ibig sabihin, walang nag-grow. So, class, ano ang MIC ng patient ko? MIC niya, class, would be 4 milligrams. Okay? So, 4 milligrams. Now, out of the 4, tapos igagamit natin kasi yung standard MIC ng patient. Okay, let's say, for example, ang standard MIC ng vancomycin, hindi ko sure kung ano eh. Pero sabihin natin, class, it's, ano ba? Kunwari, class, 1.5 milligram. Okay? 1.5 milligram ang standard MIC niya. So, therefore, class, ang gagawin natin dyan, 4 divided by 1.5. Ang magiging MIC niya, class, so divided by 4, kasi 4 para sa bacteria na to, sa S. aureus na to. So, 1.5 divided by 4 divided by 1.5. Nawala ba ako ulit? Okay, hindi naman ako nawala, right? Hindi naman ako nawala. Okay? So, this would be, sorry about this. Nawala ng onte. Okay, sorry. Ayan. So, 4 divided by 1.5. Okay, so 4 divided by 1.5. Okay, 4 milligram kasi yung ano ko eh. Yung dose na MIC ko dito. Tapos 1.5 yung standard. Ang nangyayari class is 2.67. Yung MIC nung bacteria na to sa vancomycin ko. And that's greater than 1. Okay, so class, basta ang MIC is greater than 1, okay, if it's greater than 1 class, then that indicates na, tawag dito, resistant yung bacteria na yon sa vancomycin ko. Okay? So, halimbawa, class, kunwari lang naman, what if yung standard MIC of vancomycin is equal to, let's say, 8 milligrams. Okay, yan yung standard. Now, class, dito, makikita natin, at 4 milligrams, no growth na raw. At 4 milligrams, no growth na yung bacteria. So, therefore, class, that's just 4 divided by 8. So, 4 divided by 8 would give us 0.5. And 0.5 class is less than 1. So, meaning, susceptible yung bacteria na yun sa antibiotic ko. Alright? So, let me check nga. Ba't ba ako naguhula? Pwede naman check yung vancomycin MIC. Ay, sorry, against MRSA. MRSA. Ano ba yung standard MIC? Ayun! Ang standard daw class na MIC niya is 2. Standard ng M ng vancomycin is not 8 mg, it's 2 milligrams per liter. Yan yung standard MIC niya. Okay? So, for this SRUs, in this case, that's 4 divided by 2. You get 2. Right? And that 2 is greater than 1. So, resistant yung SRUs na to sa vancomycin. Right? So, I hope that's clear, class, on how we get your, ano ibig sabihin ng MIC. At pag sinasabi kong less than 1, greater than 1, okay, based yun sa standard MIC ng antibiotic na yun sa specific bacteria na hinahanap niya. Okay, sa specific species ng bacteria na yun. Alright, so in this case, it's MIC is less than 1. So, ibig sabihin, yung culture na SRUs na to for the patient is susceptible to our vancomycin. Okay, so pharmacy is then consulted for vancomycin dosing. So, first problem, determine an appropriate dosing regimen of vancomycin to achieve a desired C-peak of 26 milligrams per liter, drawn 2 hours after the 2-hour infusion. Okay, and approximately 12 milligrams for the trough. So, nag-specify na sila. Ito yung mga targets natin. How many doses are required to reach steady state? Right? So, here, class, ang gagawin natin ay ang sumusunod na step-by-step procedure. So, first, get the K and VD. Similar again to aminoglycoside dosing. So, we get the population estimate. We determine the dosing interval. Okay, determine the infusion rate. Okay, kung ano yung dose na ibibigay natin for 2 hours. Then, check if the trough is within the desired range. Okay? So, some notes lang, class. After infusion of vancomycin, it has a distribution phase of 2 hours. With this assumption, getting the peak concentration 2 hours after the infusion, we can fit the curve in a one-compartment model. Yun sinasabi ko kanina. Okay, na kaya after 2 hours after the infusion pa tayo kumukuha ng peak plasma concentration niya. So that we can ignore the distribution phase. So first, to determine the K. Alright? Okay. Discard yan. Okay, so for this part, vancomycin. Okay. So let me show you guys how we use the Excel sheet for vancomycin. So again, guys, kailangan lang naman dito is creatinine clearance. And our patient is, let me check, female nga ba? It's a man, 5'10" in height. So sa male dosing tayo. Age niya is 42 years old. Height niya is 5'10", so that's 70 inches. Okay, ang weight ng patient natin is 90 kilograms. Ang bigat niya. So, overweight siya. Alright, so we'll be using the ideal body weight, which is 73. Serum creatinine is 1 milligram per deciliter. Okay, and then the creatinine clearance is 99. Okay. Yeah. So, if we do this, class, okay, so 99 ng creatinine clearance, tapos we use the formula, okay, lalabas kasi 0.087. So, in my case, ito yun. 0.0869. Okay, ang desired peak daw natin should be 26 times 12. Okay, same lang pala dito. So, 26, tapos ang desired trough is 12. Oops. Okay. So, as for VD, nandito na ba yung VD ko? Ako na-compute yun eh. Okay, VD is 81 liters. Automatic na nagko-compute to. Okay, so we have 81 liters here. Then we start to compute for the best dosing interval. So, here we go. Infusion time. Sabi natin, 2 hours. Okay, so ang dosing interval class 12.89. Dito sa akin. Okay, if you do mano-mano, 12.89 na lalabas. Okay, here, sa Excel sheet, sabi niya 12.9. Nag-round off na siya. Sabi si class, kung 12 yan, most likely, I'll be doing every 12 hours. Okay? Oh, some things that you have to remember, yung T prime here is the additional 2 hours extra time from end of the infusion until level is drawn. Okay? So if you're trying to compute class for peak concentration, okay, di ba normally pag nag-peak concentration tayo, wait, let me just shift 5. Okay. Normally class when we compute for peak concentration, ito lang, right? Dito lang tayo. Now you have to remember class, when we're using this formula, yung peak concentration na kinocompute natin, nandito yung concentration na yon. Okay? Ba't tayo naglagay ng E negative KT prime here? Which is yung percentage remaining after 2 hours waiting for the end of the distribution phase. Kasi remember class, ang kinukuha nating concentration, vancomycin looks something like this. So para makuha class yung concentration na to, kailangan tong idagdag. Alright? Nadagdag natin yan. Para katulad class ng formula na CP equals COE negative KT. Yung E negative KT na yan is determines the fraction of the drug remaining in the blood or in the body after a given time has lapsed. So similar to this. Okay, ang pinalaps lang natin is the extra 2 hours para matapos ang distribution phase. So kumbaga ito ay between 0 and 2 hours. So kaya dinagdag natin ito. Kasi hindi natin kailangan class ang peak concentration na ito. We don't need that. Kasi nga, sabi natin, vancomycin follows a 2-compartment model. Okay? So, ayan. Pero anyway, you can easily compute this one class using the Excel sheet that we have. Okay? So, ano naman ang maintenance dose natin? Ang maintenance dose natin class na lalabas is 1,768. Okay? Kasi i-infuse natin ito for 2 hours. So, 1,768. Dito sa akin, 1,767.64. So, obviously, ganun din naman yun. So, we'll give it at 1,700. Right? So, check na lang natin kung ano yung resulting concentration. So, pasok pa rin naman. Pero normally, class, in this case, 1,7. Pwede natin 2,000 to eh. Okay? Kung sakaling 2,000 natin, pasok pa rin naman, okay lang. Okay? I mean, it's still within range. Lumabas ba ako sa 15? Hindi naman. Hindi naman ako lalabas. Pero medyo malapit na ako, no? Which we're in, pwede nang mag-cause ng toxicity. Kung 1,000 lang kaibigay ko. Masyado naman mababa. Pinaka-safe talaga is, wait, 1,500. Para hindi masayang yung hindi ako pasok sa peak. Okay. So, wala. 1,700 talaga. Or, gusto kong i-push to hanggang 2,000, pwede rin naman. Okay na, okay na 1,700. Right, for our patient, 1,700 na lang yung natin. Okay, huwag ko nang pagpilitan yung iba. Okay, 1,700 yung dosing natin. Again, class, this is to be infused for 2 hours. Right, now what the trough concentrations, ang lalabas is 12.46 based on my computation. Okay, again, using this formula, still the same. T prime here, class, dosing interval minus infusion time minus 2 hours of waiting time. So meaning kung ang dosing interval natin is 12 hours, so that's 12 hours minus the infusion time of 2 hours minus 2 pa ulit for the distribution phase to end. Okay, so technically it's infusion time minus 4 hours. Right, kaya 12 minus 2 ito. Okay, makikita nyo dito. Alright? Okay. So next time to reach steady state, that's just half-life multiplied to 5. Andito na rin naman yun. 39.85 or 40 hours in our case here. Okay? So that's number of doses to reach steady state. So dahil every 12 hours tayo, so 40 divided by 12 gives you 3.33. Approximately 4 doses. After 4 doses, nasa steady state concentration na yung vancomycin ng patient. Okay? Now, try lang natin nga class. Ba't nga ba class natin gusto lagi nasa steady state concentration ang gamot bago tayo kumuha ng plasma concentration? Okay? Why do we prefer the drug to be at steady state concentration? Alright. Okay. Sigahan nyo na nga. Okay, normally class, we wait for the drug to be at steady state concentration because at least at that concentration, stable na yung peaks and trough concentration ng patients. Ibig sabihin, hindi na masyadong pa-fluctuate yung amount of drug in the patient's body. Okay, medyo stable na yun. Okay, we always we wait until the drug reaches steady state concentrations. Okay? Okay. So, to determine the loading dose, we can use this formula. Pero again, let's just use our Excel sheet for that. Pwede na kayo mahirapan. So, you can use this formula, class. Now, ang lalabas dyan, class, is 2,731, which is what we got here, 2,229. 2,729 here sa Excel sheet natin. Now, the thing lang, class, with vancomycin, okay, something you have to remember. Okay, with vancomycin, class, the max allowable dose is 2,000 milligrams. That's 2 vials. 1,000 kasi ang isang vial eh. We cannot go beyond 2,000. Kahit ano pa ang sabihin ng Excel sheet natin, class. Pag sinabi niyang 2,000, kahit 4,000 ang sabihin niya dyan, we can only give 2,000 milligrams for 1 dosing. Okay, for 1 dosing. Yun ay max dose niya, kumbaga. Okay, for every infusion. So, therefore, class, no choice, kailangan natin mag-2,000. Kahit sabihin dito, class, ng acting Excel sheet na ineffective yung peak concentration, carry lang. Kasi mas malaki ang risk of adverse drug reactions when you're going to use more than 2,000 milligrams of vancomycin. Right? So, again, class, that's something you have to remember, class. Okay, yun ang pinaka-max dose ng ating vancomycin. Okay, wag natin pagpilitan na magbigay ng 2,500 and so on and so forth. Okay? So, for every infusion, only 2,000 is allowable. Yun yung pinakasagad. Right? Okay. Now, this time naman, class, using actual kinetic parameters. Now, gagamit lang naman tayo, class, ng actual kinetic parameters if we have actual peaks and trough concentrations. Now, after administration of the loading dose and 7 doses, okay, so naka 7 doses na siya. So, most likely sa steady state concentration na to. At 1,700 milligrams each at 12 hours interval, plasma vancomycin concentrations are determined to be 42 milligrams per liter. Okay. So, 2 hours after the end of the 2-hour infusion. So, ito yung C-peak natin. C-peak. And 22 milligrams per liter at the end of the dosing interval. Now, if you notice, class, this is actually already way beyond the allowable concentration. Lalo na yung trough concentration niya, 22 milligrams per liter na. Sabi natin, ang pinakasagad na dyan is 20. And that is for complicated types of infection. Okay, and this one is already beyond 20. Okay, at the end of the dosing interval. So, calculate a new dose for BW to attain the original target peak and trough concentrations of 26 and 12 milligrams per liter respectively. So given the actual concentrations, you can compute now for actual PK, pharmacokinetics. And it's always better, classes, compared to the population estimate. So kung may pera naman ng patient, magpakuha ng peaks and trough concentration, yun ang gawin natin. Para makakuha tayo class ng actual elimination rate, half-life, at saka VD ng patient. Alright? So when we're getting for actual K, actual elimination rate constant, so we'll be using the actual peak and trough concentration ng patient natin. So, okay. Ang peak natin class would be 42. Tapos ang ating trough would be 22. So class, that's 12 minus 4. Bakit 4 ito? Okay, so remember class, yung 4 na yan is the 2-hour infusion time plus the 2-hour waiting time. Okay? So para lalabas dyan would be 0.0808 per hour. Most likely, 8 hours ka lang naman mag-aantay nun eh. So kumbaga class, kung ito yung graph niyan, sabi natin it follows two-compartment model. Okay? Ang peak concentration natin nag-start lang here. Ay, sorry, ulit-nan ba? Wait, let me rewrite this. Okay. So, 2 hours infusion. Pagdating dito, this is the 2-hour infusion. So, pagdating dito, gagawin mo na yan bago siya gumanon. Ito naman, 2-hour distribution phase. So, di ba dito lang tayo kukuha ng C peak. Then ito yung C trough. Right? Which is after 12 hours. So, this is 0 to 12 hours. Okay? So, from this point to this point, 8 hours lang to. Correct? So, ito lang naman kasi kailangan natin itong dalawang points na to. So, this is the 42. Ang C trough na to is 22. So, 8 hours ang nag-lapse, kaya yun yung denominator natin here. Okay, so 0.646627 divided by 8 gets you 0.0808, which is the actual KE, elimination rate constant. Okay? So, half-life would be 8.58. So, the VD naman class will be simply be determined using this formula. Okay? Transpose lang naman to ng formula natin for determining C peak. Okay? So, yung KO here would be, of course, the dose or the rate of infusion, which was 1,700 divided by 2 because 2 hours ang infusion time natin. That's 1 minus E negative KT. Right? Yeah. So, basta apply class the formula. Ang lalabas dyan na VD would be 51.27. Okay? Okay, that's the volume distribution that we'll get. Now, class, yung KT prime dito, again, this one is the, dito, yung after the, yung ating waiting time. Okay, for the distribution phase to end. Which is equivalent to 2 hours lang naman. Okay? Alright, so ito yung infusion time natin, 2 hours. Waiting time, yung ating distribution phase to end. Itong 2 na to would be the infusion time. Then of course, yung 12 dito would be the dosing interval. Right? So yung C peak natin, actual C peak is 42. And then of course, yung K natin, which is 0.0808. Now, estimation of the best dosing interval, again, we'll use the this formula here. Okay. So, ang target natin would be 26 and 12. Peak of 26 and trough of 12. So, therefore, yun ang gagamitin natin when computing for the best dosing interval. Okay, so ang K natin class, nagpalit na tayo. Ito, 0.0808 na to. Okay. And of course, the T here would be again infusion time. Ito yung distribution. So, lalabas kasi 13.58, we still stick daw with 12 hours. We should still stick to 12 hours. Now, after you get the VD and the K class, di ba, madali na lang kumuha ng ating maintenance dose. So, you can use again this formula here. Again, class, this one's quite similar to your aminoglycoside. Ang difference lang is, yun na nga, may tayo dito, KT prime, which is the distribution phase na kailangan i-consider. So again, apply the formula. Ang lalabas, class, is 526.73. That's for 1 hour. And it has to be infused for 2 hours, class. So, ang lalabas, class, is 1,053 or 1 vial na ang ibigay natin over 2 hours. Okay? Okay. So, check lang natin. So, if the dose to be used is 1,000, pero yung na-compute natin dose is 1,053. Okay? Ang desired plasma level is 26. Ang lalabas, kapag gumamit tayo ng 1,000 mg, is 24.68. Which is still okay na rin naman. Pasok pa rin naman siya halos dito. Or malapit naman sa 26 na desired natin. Now, for the trough concentration, of course, we don't want it to go beyond 15 as much as possible. And using this formula here, okay, yung T prime, dalawang prime na yan, will be the infusion and the waiting time. Okay, lalabas will be 12.93. Okay, so which is not beyond 15 milligrams per liter. Okay? Okay. That's pretty much